Okay, recording. All right, go for it.
All right, you have the floor.
Welcome to the ACM Coin event. We'll be talking about cryptocurrency and how it works and how you can potentially create your own. So, moving on. The check-in code is. Oh, wait, can you go to the next slide?
Oh,
Yeah. The check-in code is ACM to the moon, but only one of this. Wait. Yeah, only two of the zeros, O's or zeros.
yeah.
So
Yes.
make sure to check in if you have not
There is
yet
no capital O.
checked in.
Okay, now that you checked in, I mean,
All right, today's agenda, we're going to talk about what is cryptocurrency, how does it work, and we're going to talk about our own cryptocurrency, ACM Coin,
Wait, does our own check-in code work?
why you
Wait,
should
I
invest.
think it's all zeros.
Yeah,
Oh wait, oh it's all zeros. Okay,
yeah.
yeah.
there we go. Yeah,
Yes, it's
ignore
all
what we
zeros.
typed. It's a lie.
It's a lie.
Yeah, all
And
zeros.
yes, why you should invest in Dogecoin. All right,
Yeah.
off to the
Ultimate coin.
races.
All right, so what is a cryptocurrency? Yeah. So cryptocurrency, it's online currency. It uses cryptography to ensure that no one's getting robbed. You can actually use it to buy things, unlike with stocks, where you actually have to sell the stock back for money in order to use it for something. It's completely decentralized, and the prices are super volatile, as you've seen in the past few days. Thanks, Elon Musk.
Okay, so how does one mine cryptocurrency? So can I control the screen?
Yeah, you
Okay,
can.
yeah. So here's a meme, and I'll let Nishant explain himself.
I've been trying to get a graphics card for about 6 months, and I can't get anything because it's always taken, and I'm crying because I have a $1,000 paperweight of a computer at the moment. So please let me buy a graphics card. This is my pitch. Thank you.
Yes. Sad
All he
react
wants-
for Nishant.
All
Sad
he
react.
wants is a 3070.
I just want a 3070.
All right.
Okay, cool. So mining is the process by which new coins are entered into circulation. So instead of like putting actual money and getting cryptocurrency or coins, you can mine coins in order to get coins. So the way that it works is like a bunch of miners like solve a hash problem, and whoever solved the problem first gets to add a block of transaction to a blockchain. And once the transaction is verified, you will be awarded with coins. And to solve the hash problem, you don't really, there's no like really algorithm to solve the problem. It's just like a guessing game. You just have to guess the number, and then whoever gets the closest will win the game. And then since you have to like solve these complex math problem or like guess this number, so GPUs are required to do this stuff. Yep. Next slide.
All right, so coins versus tokens. What's the difference, and why does everybody talk about coins and tokens, and what the heck is a coin? So, next slide. A coin is a store, is used like money. It's a store of value. So there's no like added functionality to coin. It's just, it's like money. I'm giving you a coin, you're getting money, and then you give me back coin, I get back money. So, we only mine coins, we trade coins, and we can store it, like hold on to coins. And they're both on their own like blockchains, which we'll explain a little bit more in a bit, but they're basically like built on their own like separate code bases and separate things. So next slide. So tokens are typically not used as money, but they can be. But they're mainly used for like a lot of other things, like prepaid credit and artwork, certificates, and other things. So tokens are like built. They're built on blockchains. Typically, Ethereum is one of the most common ones that they're built on, and they're very easy to create compared to coins because you don't have to like start from scratch because you're already building your token off of another like pre-built coin. And if you've heard of NFTs, they're similar to those. Those are technically a type of token. So they're just used for like certificates of ownership or certificates of credit and stuff like that. So yeah, hopefully that clears up the differences. Yeah.
Okay, so how does cryptocurrency work? Long story short, it's just a lot of math and a lot of hashing. Next slide. So the first thing that you have to do when you make a cryptocurrency is give each transaction a digital signature. This is just so that each transaction is able to be identified and unique. The digital signature is generated with a public key and private key pair, as well as the message. And then the message also needs to have an ID so that each message is unique and you can't basically create fraud. Next. Yeah, so the signature is created with a function that generates a 256-bit string. And yeah, 256 bits, that's 2 to the 256 different combinations, which is just a lot of combinations. So that's not something that you can just guess out of pure luck. The signature is verified through a function that takes the message, the signature, and the public key. And you really just cannot get the right encryption without the secret key. So this ensures the validity. Yeah, we can go next. So the ledger system is a system where that the goal is to decentralize the transaction process. So you don't want one person controlling all the money and distributing it. You want it to be basically like everyone has a copy of all the transactions. And then this is basically when someone pays or gets some cryptocurrency, this transaction is broadcasted to everyone. One problem with this is that it's possible to make fraud transactions and then broadcast it. So then there's other ways to prevent this, which we'll talk about soon. Yeah, so hash functions that are used, SHA-256 is one of the most common hash functions that's used. If you actually inspect some of your websites and you check on security, they're most likely using SHA-256. So I tried it with YouTube and it's true. I saw SHA-256. The reason why people use it is because it's very easy to verify when you have the secret key, but it's so difficult to reverse engineer. So you can't really make frauds. Yeah, so then you take blocks of transactions and then you hash using SHA-256. These blocks of transactions are then linked together. This is what is creating the chain. The chain of blocks is what's called the blockchain. The blocks have to have the previous transaction as a header so that we know the order of the transactions. And then at the end of each block, there's a proof of work, which Connie kind of talked about, and that's how miners are going to be getting their cryptocurrency. Yeah, so explaining proof of work, in order to validate the block, you have to provide a proof of work. And the goal, or this is like for Bitcoin specifically, but a lot of cryptocurrency, you have to find a correct input that hashes with SHA-256 to have a certain number of zeros in the beginning. So for example, Bitcoin, they cycle through different numbers. They just like randomize it. Sometimes it's 12, sometimes it's 30, sometimes it's 56. And then it changes every so often. And then you have to find the input that when you hash it, it'll give you exactly like 30 zeros in the front. Yeah, so that's 1/2 to the 30, for example, of 30 zeros. That's 1 in a billion chance of randomly happening. And you have to guess it, which is why GPU is necessary to do this. Yeah, so as Connie said, it takes a ton of computational work. It's impossible to do it like without a strong computer and a strong GPU. And because it takes so much work to verify each blockchain, the longest blockchain is taken as the correct sequence of transactions. And this is what ensures integrity of the system. So for example, let's say that I have a fraud transaction and I put it into the blockchain. I would have to keep pumping out fraud blockchains faster than every single miner who is mining the actual blockchain. So yeah, that's virtually impossible for a single person to beat like everyone else in the world with GPUs, which is why the longest one is taken as the correct sequence.
All right. So what about making a coin? I would say just Google it. It takes like 5 minutes. That's what one of the first guys told me to do, but I can't do that. All right, next slide. Okay, so step 1, pick any object-oriented language. This could be Python, Java, C++, whatever. As long as it's object-oriented, you can do it. Next, you need to make a blockchain object, a block object, a transaction object, and a way to calculate the hash. So blockchain object is primarily just a list. Just want to make sure all the blocks are in order. Blocks need a hash function. They need to store the previous hash, the transaction, and the time the block was made. All that gets stored in the block. The transaction object needs a sender, a receiver, an amount, a time it was made in its own hash function, and to calculate the hash, you can just use SHA-2, as mentioned earlier. Now, you also need to make a proof of work algorithm, which allows for mining, a key generator, okay, that just depends on the library you use. But, people can't really use the cryptocurrencies without keys. Otherwise, everyone's stuff's gonna get stolen. And then optionally, you can make an interface. Now, I have an example of someone's cryptocurrency down below. Mind clicking on that?
Yeah, you can show that. Does it show up?
Yeah, it does show up. I think you might want to zoom in though. It's really small.
Okay.
So here is the example of someone's coin. I think if I remember correctly, this was used for Jim Coin, which is someone's personal project I found on YouTube. So you see here, there's the blockchain object. This is all written in Python. Forgot to mention that. Like you can register nodes, resolve conflicts. We keep going down. Add transactions. Like there's a lot of stuff here.
Yeah.
And look at all this stuff.
Yeah. And that's
That's
like
awesome.
the entire thing, right? So,
Yeah, that's the whole thing.
yeah. Okay.
All right.
Okay, so now that you kind of know the ingredients that you need to make like some type of cryptocurrency, you might want to look into the different variations of how these cryptocurrencies are made, because different cryptocurrencies tend to serve different purposes. They're not all just like for people to buy a whole bunch of it, sell it, make money off of it. They actually are trying to solve some sort of problem or provide just a different way of where you can put your money. So, and the two biggest ones, of course, are Bitcoin and Ethereum, and others that I'm sure you've heard of. Okay, but first we're going to focus on Ethereum and Bitcoin. So there's this cool website called TX Street that is like literally showing, it's literally a live visualization of how often these transactions are being made. So if I go to the website, hopefully it works. Yeah, we have Bitcoin on the right. You can see these blocks. So these are the actual blocks where it is filling up with a whole bunch of people to make transactions. And you can compare that to Ethereum, where the blocks are a lot smaller and actually going at a faster pace. There's a lot of complicated stuff on this website that I don't understand, but I think if you scroll down, you can see how like there's all these people in the little fee line that are trying to get into each coin. And then you can see how much more often the Ethereum is happening. And generally, I think these like signs are saying, the time. So like the last block of Ethereum was only like 16 seconds ago, and Bitcoin, it said like 8 minutes ago. So you can see like they have changed the time at which these transactions are happening. So yeah, so here's like a list. Bitcoin is mainly a payment system, a universal way to make more transactions, just hopefully seems like a lot of bigger companies are trying to take advantage of it, like Tesla was attempting to until they realize that it's not energy efficient at all. And hopefully that changes. Bitcoin is kind of unique in the sense that there can only be ever 21 million Bitcoins. And, you know, if you know that when you're mining, the rate at which you can mine halves every, I don't remember the how often, but every once in a while the reward is halved. So that means that the last one will be mined in 2140 unless the developers add more, so you can actually mine more. But Ethereum is different. There's no limit on the amount. There's only a limit on how many are released annually. There's like an annual cap. And maybe this is why Ethereum doesn't cost as much, but it's also a little bit newer. So, but the other thing that Ethereum is good for is these NFTs, and apparently it's good for like just like storing computer code. So I guess it has a lot to do with putting kind of things that you want to store and making them have a value in a way. And I think the current reward per block is just like 5. Yeah, so that's everything that we have for today. Thank you for attending and watching.
Thank you.
Thank you.
Any
Thank
questions?
you.
Any cues?
Oh, hi, Shravan.
What's
Alright.
up?
You came at the very end.
Yeah. Shout out to the TED Shadowers.
Thank you.
They are not board members, and yet they have put the time to make this presentation, and I really appreciate that.
Thank you, Kyle.
Yeah. Good job, y'all.
Thank you.
Appreciate it.
All right, I'm gonna stop the recording.
I thought only
All
one
right.
of us isn't bored.